Okay, so we've all been there, right? You try to run an HDMI cable more than, what, 15, 20 feet, and suddenly everything just falls apart.
Oh, absolutely. The signal just drops off a cliff.
Exactly. So today we're doing a deep dive on a specific piece of hardware that claims to fix that exact headache, for the pro world at least. It's the Kramer DTAXR-IN4-F32.
It's quite a name.
It is. We've got the data sheet, the tech docs, and really our mission here is to figure out if this kind of proprietary hardware still holds up, in a world that's moving so fast toward IP-based solutions.
Right. And to be clear, this isn't a standalone box. It's a 4-channel input card.
For the big VS3232 chassis, yes.
Exactly. It's designed specifically for those modular matrix switchers. So you're slotting it into, like, the central brain of a building's entire AV system.
Okay, so looking at the specs, the core technology here is HDBaseT. But this isn't just your standard extender you'd buy online.
No, not at all. This is using what they call extended reach or XR technology. Standard HD-based TT, it often hits a wall around 70 meters for the good stuff. This is engineered to go way beyond that.
Over standard copper cable, too.
Yep, just a regular twisted pair cable.
But I did notice something looking through the datasheet. The bandwidth, it's listed at 10.2 gigabits per second.
Ah, yeah, you noticed that.
I mean, for anyone who follows HDMI standards, we're always looking for that full 18 gigabits for premium gear. So what's the story there?
That is the trade-off. It's the compromise you have to make to get that incredible distance.
Okay.
So you still get 4K resolution at 60 hertz, but it's a 4.2.0 chroma subsampling.
So you're shedding a little color data.
You are. It's a calculated compromise. I mean, for most people in a boardroom or a lecture hall, you're never going to notice it. And in return, you get rock-solid stability over these really long runs.
And those runs are impressive. The sheet says 100 meters, so what, 328 feet for that 4K signal?
Which is already very solid.
It is, but the part that really made me, raise an eyebrow was this ultra mode.
Yes. That's the standout feature. That's the real magic here.
What does that get you?
If you're willing to drop the resolution down to 1080p, this card will drive that signal up to 180 meters.
180 meters, that's almost 600 feet.
Nearly 600 feet. On copper.
That's massive. You're talking about wiring an entire university hall or like a corporate campus building without even thinking about fiber at that point.
Right.
But, okay, usually when you push copper that hard, you start losing things, the control signals, the other data. Is this just a dumb video pipe?
Not at all. And that's really the key here. It maintains the full HDBaseT promise, so you get full bidirectional communication.
Yeah.
It's tunneling Ethernet, RS-232, and even infrared right alongside the video and audio.
Which is critical. I mean, for any of the integrators listening, that means you can sit in the rack room, fire a command through the matrix, and, turn on a projector 500 feet away.
And you don't have to run a separate control line to do it. It's all on that one cable.
A huge time and cost saver.
Huge. Plus, it handles audio. It has selectable audio, so you can embed or de-embed analog audio right there on the same jack. It gives you a ton of flexibility at the rack.
All right, let's talk about the elephant in the room, the price. This card is listing for around $2,304.
Oh, yep.
That's a lot of money for 4 inputs, especially now in the age of, cheap AV over IP encoders. Is that price tag still justified?
It's a really valid critique. And look, you could definitely find cheaper ways to move video from point A to point B.
Right.
But with a card like this, you're paying for reliability, for a dedicated circuit. This signal is not sitting on the client's IT network with all their other data traffic. It's a direct pipe.
So it's the difference between it should work and it will work.
Exactly. For a mission-critical install, like a command center or a big surgical suite, that peace of mind often justifies the premium cost.
Which brings us to, I think, the bigger question about the future here. We have this, this $2,300 card that's keeping the traditional big iron matrix switcher alive and well.
It is.
But AV over IP is becoming the standard for flexibility. It's scalable. It's easy. Are we kind of looking at the last generation of these massive chassis systems?
That is the debate right now. I mean, AV over IP is wonderfully flexible, but it introduces latency. It introduces network security risks. It's another thing for the IT department to manage. A dedicated matrix switcher like the VS3232, it's a closed loop. It's basically unhackable from the outside, and the switching is instantaneous.
Yeah.
There's zero latency.
So here's the final thought for you to chew on. As an industry, What's more important going forward? Does the rock-solid security and the zero-latency performance of a dedicated matrix outweigh its higher cost and physical cabling limits?
Or is the sheer flexibility of AV over IP just too compelling? And is it finally time to cut the copper for good and just put everything on the network?
A really tough call for anyone designing a system today. Thanks for unpacking all this with me.